Welcome to this tutorial on creating augmented reality retail staff training solutions. In today's session, we'll dive deep into the nuances of AR technology and how we can harness it to improve training for retail staff. Here, we'll explore the entire development process while using Java and relevant AR frameworks. So, let's get started. Before we begin coding, it's crucial to understand what augmented reality is. AR is a technology that superimposes digital information, sounds, images, and text onto the real world. In retail, this can help new employees learn product details, customer interaction techniques, and much more. First, let's set up our development environment. We will be using Java with a framework called AR.js, which is great for developing AR applications. Let's start by downloading and setting up the necessary tools. Next, we need to create a new directory for our project and initialize it with Maven. This will help us organize our project files and dependencies. Now that we've initialized our project, let's move into our project directory and open it in your preferred IDE, such as IntelliJ IDEA or Eclipse. In your IDE, navigate to src/main/java/com/retail/training. Inside, you'll find a sample app.java file. We will be building our AR application here. Let's rename this file to artrainingapp.java to make our purpose clear. The next step is to set up our dependencies in the pom.xml file. This is where we declare the libraries we need for AR.js and any other utilities. Now we will set up our basic AR scene. Create an HTML file in the src/main/resources directory called index.html. This file will host our AR implementation. In this HTML code, we create a simple AR scene with a box that appears when the hero marker is detected through the device camera. Test it out by printing the marker on paper and pointing your camera at it. Now let's integrate our Java backend with this HTML page. We will serve the HTML file using a small Java HTTP server. First, we'll need to add two dependencies: Spark Core for the web server and JSON for JSON handling. Update your pom.xml as below. Next, let's write the code to serve our HTML content. Open artrainingapp.java and implement the following. You can run this application by executing mvn clean package followed by Java cp target/artraining 1.0 snapshot.jarcom.retail.training.artrainingapp. This will start a local server hosting your HTML file. Great! With our server running, open your web browser and go to http://localhost 4567. You should see your AR scene with the box that reacts to the hero marker. If everything works correctly, high five. Now, let's enhance our AR experience by integrating more interactive elements. Employee training can involve cues or information to help improve product knowledge. We can overlay text in the AR environment. Modify your index.html file as follows to include a text element. In this modification, when the hero marker is detected, it will display a plane with product information written on it. This is quite useful for training staff about specific products and promotions. Let's look at another scenario, simulating customer interactions. We can use scripts that foster decision-making skills in employees. In your index.html, let's add an interactive button. Next, we will add interactivity to the button, for example, to create a prompt when it is clicked. The code can be added below, utilizing the A-Frame event listener. Now with this setup, clicking on the blue box will trigger an alert, simulating a response to a customer's query. It creates real-time engagement as employees practice their customer service skills in an AR environment. Let's explore how we can gather training results. During their interactions, we can record their performance and display it once the training is completed. One approach is to use a simple scoring system added to our Java backend. This segment of code will create a performance evaluation API that returns a JSON object with the score and feedback after the training session is concluded. It can be called to fetch results once the training is completed. Finally, let's wrap up our small VR training application. You can think about how to scale this application. Consider storing user data or feedback in a database for performance analysis over multiple sessions. In this code, we start the H2 database server and connect to it to store training results. This allows for continued development on how we can analyze training data for insights into your staff's development. To conclude, you have successfully built a modular AR application that serves as an effective training tool for retail staff using Java. This could significantly enhance the training experience, making it more interactive and engaging. Thank you for following along with me in this tutorial. Don't forget to like, subscribe, and hit the notification bell for more in-depth programming tutorials. See you in the next video.